Today we're going to start our final lesson on laws of exponents. We're trying to push through this because we're running out of time, and I know the lessons are long, but this is our last one. Let's review our laws of exponents. In our second lesson, we introduced the identity property, which says any number raised to the first power is that number that we started with. Or if we start with a number, we can also write it as that number raised to the first power. And sometimes we'd like to see a power, particularly when we're using another property, and sometimes we'd rather just look at the number as is. The second law is a zero property. If I raise any base to the zero power, the answer is 1. And we talked about that the other day when we used our calculator. The product law, also known as the property of exponents for multiplication, says if I take a base and raise it to the nth power, and I'm multiplying that same base raised to the m power, then I keep the base and I add the powers. So when we see multiplication, as long as the bases are the same and we have exponents on both, we can add the powers. So see multiplication, do addition. Yesterday's lesson was the quotient law, also known as the property of exponents for division. So if I have a base that's raised to the nth power and I'm dividing by that same base raised to the m power, then I can keep the base and I take the top power n minus the bottom power m. And this one, order matters. So another way to look at this is I see division and I do subtraction with the powers. So today I'm just going to preview what the power is that we're going to use. And this says that if I have a base raised to a power and then that whole thing is raised to another power, then I'm going to keep the base and I multiply the powers. So a power raised to a power. Sometimes there's more complex. They have more than one base inside and they might be raised to the same power or different powers. But if that expression is raised to a power, then I keep the base and I multiply the power that's in front of them with the first base times the power outside. And then I keep the second base and multiply the power that goes along with it with the power outside the parentheses. And we'll do some numbers. We'll work with numbers to see how this works. We will be using the product law to kind of go through and see what the answer looks like used in a different form, or to kind of prove the power of power law. So please find the page that says a power raised to a power. Okay, so the first law, and I just wrote it a little bit differently. I started with n instead of m the last time. We see the law written here, and of course when I see it like this, it doesn't make as much sense as it does when I use numbers. So it says, let's explore what this looks like, and we're going to use the product law to help us simplify the expression first, and then look for other patterns we see. So if I start with 9 to the 5th power, and that whole expression raised to the 2nd power, well, I'm going to take 9 to the 5th power once, and then I'm going to take it twice. I'm multiplying that expression times itself. Now that I've expanded that, or quasi-expanded it, not fully expanded, I'm going to now, I can see I can use a product law. I'm going to keep the same base, and I'm going to add the exponents. So if you recall, when I see multiplication, I add the exponents. And so the answer to that is going to be 9 to the 10th power. So I want you to look at what the answer is, and then I want you to look at these exponents. Can you see another way that we can come up with 10 using what's written? Well, you may have noticed I could keep the base, and if I multiplied 5 times 2, if I multiply the powers, I'm going to get that same 9 raised to the 10th power. So let's see if this works if we use it again. I'm going to start with the expression inside the parentheses. So I'm going to write 7 to the 4th power. And the exponent outside says I'm going to multiply that by itself, and I should multiply it by itself 3 times. So there's 3 of the expressions inside the parentheses. So now let's try using the product law now that we have this quasi-expanded. So the product law says that if I have the same base and it's being multiplied, if I see multiplication, I do addition. So I'm going to keep that base of 7, and I'm going to add 4 plus 4 plus 4. And when we complete that, we get 7 to the 12th power. So now let's try using the power of power law. And last time we looked at 4 and we looked at 3, and how can we use 4 and 3 to come up with 12? Well, if you notice, we can multiply again. You're correct. We're going to keep the same base. I'm going to start with a power on the inside and multiply it by the exponent on the outside. So I will get 7 raised to the 12th power. Let's try this process one more time. The expression on the inside is a to the 2nd power, a squared. And I'm going to show this 6 times. So a to the 2nd power times a to the 2nd power times a to the 2nd power, a to the 2nd power. I'm going to have to go down to the next line, times a to the 2nd power times a to the 2nd power. Now that that's expanded, I can use the product law, which says I'm going to keep the base and I'm going to add all the exponents. If I see multiplication, I do addition. So let's count. 1, 2, 3, 4, 5, 6. Exactly right. And if I added those all up, I get a to the 12th power. And you can see that's kind of the really long way to do this. Once we discover the rule or understand the rule, power to a power law, I would simply take a and I would multiply these exponents. So this is the expression on the inside, and I multiply the exponent on the inside by the exponent on the outside. So our answer should be a to the 12th power, just like we found the long way. So I'd like you to try now using this power, and would you please complete A, B, and C on your own. B and C are a little bit tricky because we threw in some negative numbers, so you want to use your marker faces and then check back for the answers. All right, so A is the final answer, should be 8 to the 20th power by multiplying 4 times 5. Y, we had to remember our Margar face, a positive times a negative is a negative answer. 6 times negative 2 is negative 12. And on this one, base of 21, I multiply negative 3 times negative 4. Again, a negative times a negative is a positive. So 21 to the 12th power. Now let's go ahead and try a little bit more challenging law. Please turn to the back side of the paper. The second part of the law looks like this. Sometimes we have more than one number or variable inside the parentheses. We multiply the power on the outside of the parentheses with all of the powers on the inside of the parentheses. So let's expand a few examples to see why this works. So we're going to use the expression, the whole expression on the inside of the parentheses, and the power on the outside says we're going to see it twice. So 5 to the 3rd power, W to the 4th power, times 5 to the 3rd power, W to the 4th power. So I'm squaring that expression. So now I'm going to use a product law, but when I use a product law, I need to gather up my like bases. So I'm going to start with the 5s. There's a base of 5. And remember, if it's side by side, it means it's being multiplied. So we're allowed to take this in any order we want. Everything's being multiplied. But our product law says that we take like bases and we add their exponents when they're being multiplied. And so now I'm going to take W, and I see as a base, and the exponents are both 4. So I'm going to get 5 to the 6th power w to the 8th power. So if I use the product law, it's almost like using the distributive property. This 2 is going to multiply this 3, and this 2 is going to multiply this 4. So here's what it looks like when we use the power of a power law. We're going to start with a base of 5, and I'm going to take the inside power, which is 3, and multiply it by the outside power. Then I'm going to use the next base of w, and the power above w on the inside is 4, so the inside power is 4 and the outside power is 2. So if I took 5 and multiplied 3 times 2, I would get 6. I'm going to use the base of w, and the power is 4 times 2. I'm going to get 8, and exactly the same answer. The power of power law is a little bit more efficient. So let's try another example. We start by taking whatever's inside the parentheses, the expression inside, and this time I have to write it 3 times. It's going to be multiplied 3 times. So a to the 6th power, b to the 5th power once, a to the 6th power, b to the 5th power twice, a to the 6th power, b to the 5th power 3 times. This outside parenthesis says I'm cubing whatever inside there. So now I'm going to use the product law to help me finish this. I'm going to start with a. If I take a, I see I'm adding 6 3 times. So a6 plus 6 plus 6 times b, and this time b is 5 plus 5 plus 5. And so the final answer would be a to the 18th power times b to the 15th power. Well, that was sure a long way to go. So let's use our new power of power law, which says I'm going to take the first base of a, and I'm going to distribute this 3 with it. So I'm going to start with the power that's on a, which is 6, and multiply by 3. Then I'm going to move on to my base of b, and this 3 is also going to multiply at 5. So the exponent on b is 5, and I'm going to multiply it by the outside exponent, which is 3. So when I do that, 6 times 3 is 18. b, 5 times 3 is 15, and we get exactly the same answer in a much more efficient way. Our very last example might be a little bit different and confusing because you notice that the 2 doesn't have a power. So this is when we use our identity property, and sometimes that kind of helps us. If I put 1 there when I go to use my power of power law, it might be helpful, and I can use it also when I expand. So let's try that. I see an exponent of 3, which means I'm going to see 2 to the first power, x to the third, and I'm going to see this 3 times because that's what the outside power says. Okay, that's a long way, and we could even expand it further if it's helpful, but we're trying to make this not quite as long. So now I see a base of 2, and I see I'm going to use the exponents, adding those up, and now I'm going to move on to my base of x, and I see 3 plus 3 plus 3. When I see that it's being multiplied, I add them. So I'm going to have 2 to the third power and x to the 9th power. So let's see what that looks like if I use the power of power law. So according to the power of power law, I'm going to take this 3 times this 1. I'm going to keep my base of 2, and I want to use that power of 1 to help, and I'm going to multiply by the outside power, which is 3. Then I'm going to use the base of x, and inside it has a power of 3, and this outside power of 3 multiplies it. So we should have 2 to the third power x to the 9th power. And either way we go, we get the same answer. This is quicker, and we prefer quicker. So what I'd like you to do now is I'd like you to go ahead and try the next 3 examples and play the video back when you're done to check. Thanks so much. Okay, here's what we should have based on our work. And I did want to address something. When I write this a long way, I usually use a times dot to kind of put space and separation between the 2 bases. However, when we write our answer, we put them side by side without the multiplication sign, as long as I have a number and a variable or 2 variables. Thanks for listening, and have a great day. Bye-bye.